Steel, a material of incredible versatility and durability, is the backbone of modern infrastructure. From towering skyscrapers to intricate machinery, steel's resilience underpins countless applications across industries. This story takes us through the meticulous process of steel production at the ThyssenKrupp CSA steel mill in Brazil, from raw material extraction to the final high-quality product. To produce steel, high-quality iron ore and other raw materials are essential. Globally, iron ore is mined in staggering quantities, over 2.5 billion metric tons annually, to meet the demands of industries worldwide. The process begins with mining companies extracting ore from deep within the earth, using advanced machinery to access and process the ore on a massive scale. At ThyssenKrupp CSA in Brazil, the first step is obtaining high-purity iron ore, sourced mainly from mines across the country. Massive trucks transport the ore from these mines to processing facilities, where it's crushed and refined to meet the steel mill's strict quality requirements. This preparation ensures that only the highest quality ore enters the steel production line, reducing waste and maximizing efficiency. Before iron can be produced, a critical raw material known as coke, a carbon-rich substance derived from coal, must be prepared. High-quality metallurgical coal is processed in the plant's coking ovens at extremely high temperatures. As the coal is heated, volatile compounds are burned off, leaving behind a pure carbon form called coke, which will act as both a fuel and a reducing agent in the iron production process. With both coke and iron ore ready, the materials are fed into the plant's towering blast furnace. The furnace, heated to around 1,500 degrees Celsius, 2,732 degrees Fahrenheit, initiates a series of chemical reactions. First, the coke burns in the presence of preheated air, generating carbon monoxide, which acts as a reducing agent. This carbon monoxide reacts with the iron ore, stripping away its oxygen and resulting in molten iron, often referred to as pig iron due to its high carbon content. As the iron melts, it collects at the bottom of the furnace, while impurities rise to the top, forming slag. The slag is removed and repurposed in other industries, such as cement production, showcasing ThyssenKrupp's commitment to sustainability. This step is crucial, as it prepares the iron for further refinement, stripping away excess carbon to transform it into steel. Next, the molten iron is transferred to an electric arc furnace, EAF, where the actual conversion to steel takes place. At ThyssenKrupp CSA, this stage exemplifies modern steel production technology. The EAF operates with powerful graphite electrodes, which create an electric arc reaching temperatures as high as 3,000 degrees Celsius, 5,432 degrees Fahrenheit. This intense heat melts the iron, allowing for precise control over its chemical composition. Scrap steel is added to the EAF, reducing the reliance on raw iron and increasing the overall sustainability of the production process. The molten mixture undergoes a controlled burn-off process, where high temperatures remove impurities such as sulfur and phosphorus. This refined iron, now transitioning to steel, has reduced carbon content and improved purity, characteristics essential for creating high-quality steel. After the EAF process, the molten steel undergoes secondary refining to ensure it meets ThyssenKrupp's stringent quality standards. During this stage, alloying elements such as chromium, nickel, and molybdenum are added to enhance specific properties, such as corrosion resistance or tensile strength. Each batch is customized to meet the desired specifications for different applications, from automotive to construction-grade steel. The refining process also includes techniques like vacuum degassing to remove trapped gases, further purifying the steel. By controlling the temperature and chemical composition with extreme precision, ThyssenKrupp's engineers ensure that the steel produced meets the high-performance standards expected by global clients. With refining complete, the molten steel is ready for casting. At ThyssenKrupp CSA, the steel is poured into casting molds to form slabs, which are easier to transport and process. During casting, the molten steel flows through a cooled mold, where it begins to solidify. As the steel solidifies, it is continuously drawn downwards, creating a solid slab of high-quality steel. This continuous casting process is highly efficient, allowing the plant to produce large volumes of steel quickly while maintaining consistent quality. The resulting slabs are then cooled and inspected before moving on to the final stages of processing. In the final stage, the steel slabs are heated and rolled into sheets, beams, or other forms, depending on their intended use. At the ThyssenKrupp facility, state-of-the-art rolling mills shape the steel with precision, ensuring uniform thickness and quality. Each batch is subjected to rigorous testing to confirm that it meets both the plant's high standards and the specific requirements of clients. Some steel is further processed to add coatings or finishes that improve corrosion resistance or prepare it for specialized applications. Whether destined for automotive manufacturing, construction, or industrial machinery, the steel produced at ThyssenKrupp CSA undergoes extensive quality control, ensuring it meets the exacting standards demanded by today's industries. From raw material extraction to final processing, the steel production process at ThyssenKrupp CSA represents a blend of tradition and cutting-edge technology. Each stage reflects the company's commitment to sustainability, quality, and innovation. ThyssenKrupp's ability to produce high-quality steel on a massive scale helps support infrastructure projects and technological advancements worldwide. In the modern industrial landscape, the strength and reliability of steel are essential for various sectors, from automotive to construction. Gerdau's process integrates recycling, refining, and precise alloying to ensure that their steel products maintain consistent, reliable quality. They begin with recycled scrap steel, which is not only sustainable but also cost-effective. Recycling scrap steel requires strict selection criteria. Every piece is carefully inspected to ensure it meets Gerdau's standards, as even slight impurities can affect the quality of the final product. Once the scrap is sorted, it is transferred to the electric arc furnace, EAF, a powerful machine that heats the metal using electrodes. This furnace is equipped with oxy-fuel burners to speed up the process, reaching the molten state quickly. The EAF can reach temperatures exceeding 3,000 degrees Celsius, high enough to melt steel and prepare it for further refining. During this melting phase, various impurities and contaminants are removed from the molten steel. The intense heat causes unwanted elements to separate, allowing the bulk alloy additions to be stirred evenly into the molten metal. This process ensures that the steel bath achieves a uniform composition, laying the groundwork for a consistent and strong end product. Following melting, the molten steel is poured into a ladle, a specialized vessel where further refinement occurs. At this stage, Gerdau covers the steel with a synthetic slag, which serves two purposes. It insulates the steel to prevent heat loss, and it prevents the molten metal from oxidizing by blocking exposure to air. This controlled environment is essential to avoid impurities and to keep the metal's quality intact. In the ladle furnace, more alloys are added to the molten steel to meet specific customer requirements. The mixture is carefully stirred, allowing the alloys to dissolve evenly. Argon gas is used throughout the process to encourage homogenization and aid in removing non-metallic inclusions. The ladle furnace stage is crucial, as it ensures that the steel achieves the desired chemical composition and meets the stringent standards required for various industrial applications. To further refine the steel, Gerdau employs vacuum degassing, a process that removes undesirable gases like hydrogen and nitrogen. By applying a vacuum to the molten steel, these gases diffuse out and are absorbed into the surrounding fluxes, which helps prevent internal defects in the final product. This process is particularly important for applications that require extremely durable steel, as excess hydrogen or nitrogen can lead to brittleness. After refining, the steel is ready for casting. Gerdau uses two casting methods, rotary casting and strand casting. Rotary casting. In this method, the ladle delivers the molten steel to a tundish, a distributor that directs the liquid metal into rotating molds. The molds spin, using centrifugal force to push the molten steel against the mold walls, which cools and solidifies the metal from the outside in. This rotation helps create billets and blooms with even properties throughout the steel, ensuring that each section is consistent in strength and durability. The molten steel flows through a ceramic shroud and enters a tundish protected by argon gas. Electromagnetic stirring creates uniform heat distribution, which, combined with controlled water spray zones, cools the steel in a way that produces billets with uniform properties. Gamma radiation detectors continuously monitor mold levels, and automatic adjustments ensure high-quality outcomes. Once solidified, the billets move to Gerdau's rolling mills. Here, they're reheated to the optimal temperature for shaping. Any scale formed on the surface during heating is removed before rolling, ensuring the steel's surface remains smooth and clean. Gerdau's precision rolling mills can produce bars of varying diameters, from as small as 5/8 of an inch to 6 inches, with tight size tolerances. This precision is essential, as it allows Gerdau to meet the specific needs of industries that demand high-quality steel components. Each bar's length is controlled using hot saws, and larger bars can be automatically chamfered to further refine the final product. Gerdau provides several in-house finishing options to customize steel for specific applications. For example, their Mac Plus cold finish bars are turned and polished to a smooth, bright finish that improves machinability and weight control. Additional processes such as inline bar straightening, surface inspection, and ultrasonic internal inspection are used to ensure that the final product meets all quality standards. In the Huntington facility, Gerdau uses a proprietary quenching and tempering process to produce high-strength bars. Each bar is heated, quenched, and tempered individually, resulting in a uniform structure that's durable and stress-free. Quality is integral to Gerdau's process, and they implement strict inspection protocols at every stage. Advanced testing methods, such as ultrasonic inspections and gamma radiation monitoring, allow Gerdau to detect and address any potential defects before the steel leaves the facility. Automated inspection systems ensure that each bar, billet, or component meets the company's stringent standards, guaranteeing reliability for their customers. Gerdau invests heavily in technology and innovation to maintain its competitive edge. By constantly modernizing their processes and equipment, Gerdau is able to enhance efficiency, improve product quality, and reduce waste. This focus on technological advancement means that Gerdau can meet the evolving demands of industries that rely on high-quality steel, providing customers with products that are stronger, more durable, and consistent. Gerdau's approach to steel production and recycling is a testament to their commitment to quality, innovation, and sustainability. Through a careful blend of recycled materials, precise alloying, and state-of-the-art casting and finishing techniques, Gerdau creates steel that's not only reliable but also environmentally friendly. This meticulous process ensures that Gerdau's steel products provide the strength and durability needed in demanding industries, from automotive to construction and beyond. In summary, Gerdau's dedication to consistency, advanced technology, and rigorous quality control forms the backbone of their operations, making them a trusted partner in the steel industry. This approach is what enables Gerdau to offer steel solutions that serve as the foundation for numerous applications, empowering their customers to build with confidence and resilience.